So how do I graph a linear function using a table of values? Got a couple of things going on, and when I pulled up these notes from last year, I didn't look at them very carefully because I left the questions in, and I was supposed to take the questions out. So you got lucky. You don't have to write a question here. I did it for you.
Thank you.
How do I find out if an ordered pair is a solution to an equation? Okay, so I want to know if 3, -4, or if -4, 1, or both are solutions to this linear equation. A linear equation has an x and a y, both are to the first power, and when you graph them, you get a straight line. Line linear. That's where it comes from. So we're just going to plug and chug. Use our substitution skills here. There's x, there's y. So 2 times 3 plus 3 times -4. And if it works, we will get -6. 6 plus -12. -6 equals -6. That's a true statement. So because that's true, I can say that 3, -4 is a solution. You have to check -4, 1. It isn't a case if there's only one answer that works. Okay, when you have two variables, there's actually an infinite number of answers that work. Every ordered pair that's on the line you graph works. And just to be sneaky on the SOL, they often give you more than one that works. Okay, I saw one a couple years ago where it was one of those hotspot questions. So they listed 9 ordered pairs, and I want to say 7 of them worked. And you had to click on all 7, otherwise you didn't get credit for the problem. Okay, so make sure you always check both. Let's check the next one. 2 times -4 plus 3 times 1, -8. Uh-oh. -5 does not equal -6. So -4, 1 is not a solution. Those hotspot questions, I think they're evil because, you know, it's one problem, but you really have to work 9 or however many choices they give you in the hotspot. Hey, 3 instead of a -4. Where did I put a 3 instead of a -4? But the ordered pair, right? X is -4, y is 1.
Oh.
That makes sense? I'm using a different ordered pair? Okay. Alrighty. Sometimes they give you the graph and they ask you, are these ordered pairs a solution? So plot the points on the graph. 3, 4. 1, 2, 3, 1, 2, 3, 4. What do you think? No. Not a solution. Okay. How about 1, 4? Yes. I really like it when they give me the graph because that's pretty straightforward. It's either on the line or not on the line. All right. Now, when we did this in the last unit, I always gave you the equation in function form. I always gave it to you in y equals. That's not going to be the case in this unit. Back when we did literal equations in Unit 2, more than half the practice we did was rearranging the equation into y equals format. Most of you got to be very, very good at that. Okay, and that's because of this unit right here. Then, to graph using a table of values, you have to choose a few values for x and make a table. Make sure you choose an equal number of positive and negative values. A minimum of 3 is required for a line. Later in the year, when we're graphing parabolas, you have to do 5. But for a line, 3 is the minimum. And then just graph the points from the table of values. A line that passes through those points is the solution of the equation. It's also the graph of the equation. Okay, because there's an infinite number of solutions when you have two variables. Okay, x plus 4y equals 4. Do you remember, bless you, from Unit 2? I told you when we rearrange equations and get y equals, we wanted a certain formula to it. Does anyone remember that formula? Y equals, go for it. We want y equals mx plus b. This is called slope-intercept form of the line. We're doing a couple lessons on this next week. But we talked about it back in Unit 2 because I told you if you got in the habit in Unit 2 of always writing your linear equations in y equals mx plus b, it was going to make Units 4 and 5 easier. I'm lying. It definitely will. So I want to rewrite this so that I have y equals mx plus b. So what do I move first? Do I move the x or do I move the 4y? The x. I need the x on the other side. So now I have 4y equals negative x plus 4. I'm going to stick that x term right after the equal to sign. All right, so that I'm following the format. Now I need to divide everything by 4. So y equals negative 1/4 x plus 1. We did this back in Unit 2. You have to divide everything by the 4. All right. This is now our function. Y equals negative 1/4 x plus 1. Now on the last unit, Unit 3, we usually pick like negative 1, 0, and positive 1. And that works as long as I don't have a fraction here, but I've got a fraction here. If I pick 1, I'm going to end up with a fraction of my answer. I don't want that. So look at your denominator. Your denominator is 4. We want multiples of 4. So how about 0, 4, and 8? Negative 4 and negative 8. By picking multiples of your denominator, you will not have a fraction in your answer. Now, we did this last time. We used our graphing calculators to help us. So we're going to go to y equals. Make sure you put the fraction in parentheses. Parenthesis, negative 1/4. Close your parentheses. X plus 1. Press graph so you can see what it looks like. And then go to the table. Second graph gives you the table. So I get 0, 1, 4, 0, got an arrow down, 8, negative 1, got an arrow to get negative 4 for x, 2, negative 8, 3. I did it on my graphing calculator, so I'm not showing the substitution and solving. So my ordered pairs, negative 8, 3, negative 4, 2, 0, 1, 4, 0, and 8, negative 1. I have to graph those. 8, 3, negative 4, 2, 1, 0, 4, 0, 8, negative 1. Make sure you use your straight edge. Make sure you draw your line beyond the point you plotted, and make sure you put arrowheads on the ends. You have to go beyond the point you plotted, and you have to have arrowheads on the ends. What is the y-intercept of this line? Matthew? 1. Our y-intercept is at 0, 1. What about the x-intercept? Alicia? 4. So 4, 0 is the x-intercept. What is the 0 of this function? X equals 4. Olivia. No. All right, let's look at the next one. Oh, goody. It's not in function form. Make you use your Unit 2 literal equation skills. That always makes me happy. So 3x minus 2y equals 6. How do I move the 3x? Subtract it. So minus 3x minus 3x. So I have negative 2y equals negative 3x plus 6. Make sure that x term comes right after the equal to sign. Am I done?
Nope.
No, I need to divide everything by negative 2, all 3 parts. So y equals 3 halves x minus 3. Alrighty. Once again, I've got a fraction in front of x, so I can't pick 1 as my x coordinate. Otherwise, I'll end up with a fraction that I have to graph. I want to pick multiples of 2. So 0, 2, 4, negative 2, negative 4. And my calculator. X minus 3. Go to my table. Negative 4, negative 9. Negative 2, negative 6. 0, negative 3. 2, 0. And 4, 3. I need to take care of that before class starts, please. Negative 4, negative 9, negative 2, negative 6, 0, negative 3, 2, 0, and 4, 3. Really like that table feature on my calculator. Saves me a lot of substitution and order of operations. Negative 4, negative 9, negative 0, -3, 2, 0, and 4, 3. Make sure you are using your straight edge, that you go beyond the points you plot, and that you put arrowheads on the ends. So looking at the graph, what is the y-intercept? -3. So remember that's an ordered pair, 0, -3. What's the x-intercept? 2. So again, it's an ordered pair, 2, 0. What is the 0? X equals 2. Okay, so this time I'm also going to ask you for domain. What's my domain? Brandon?
All right. All real numbers.
All real numbers, because the line goes on and on and on and on and on forever. So that line keeps spreading out until it covers all real numbers. So our domain, x such that x equals all real numbers. What about our range?
All real numbers.
All real numbers again. And again, it just keeps going forever, up and down. Think we have one more?
No.
Yeah. Okay. Oh, and this is how to do it on our graphing calculator. Alrighty. So, we've been through this before. Pressing y equals to enter the equation of the line. Pressing graph to see it on our calculator. Knowing we can arrow up and down to see more x values. So let's put this equation in. -3x plus 4. I guess last year when I did this, I made the class do substitution for all those other problems. Actually, lucky I decided to be nicer this year. So to get to -5, ooh, 19, that's a huge number. -2, 0, 2, and 5. Looking at the y values for -5 and +5, were those good choices?
No.
No. Are they going to fit on our graph? No. Okay, so when you get to make your own tables, you need to make good choices. Don't pick numbers that aren't going to fit. Okay? I'm not even going to try to graph these two. I'm going to stick with the 3 in the middle that I can graph. -2, 10, 0, 4, and -2, -2. Using my straight edge, going beyond the points I plotted, and putting my arrowheads on. Hey, you don't have to do any questions because I left them on from last year, but you do need to write a quick summary. Take a few minutes to do that, please.